Hey everyone, and welcome. Today we're jumping right into AWS Lambda. It's one of those technologies that's really become a massive part of modern cloud architecture. It's at the heart of the whole serverless revolution. If you've ever found yourself wondering how these huge applications can scale up and down without a giant fleet of servers, well, you are in exactly the right place.
So let me just start with this one simple but honestly pretty powerful question. What if you could build and run your applications without ever having to think about provisioning, patching, or managing a single server? I know it sounds a little like science fiction, right? But it's not. That is the core promise of what we call serverless computing, and AWS Lambda is the engine that really makes it all happen.
So what is this thing really? Let's break it down. We're going to get into the core concept of what AWS Lambda is and, how it actually works under the hood.
Okay, at its simplest, Lambda is an event-driven compute service. Now, event-driven just means your code isn't running 24/7. It only wakes up and executes in response to a specific trigger, some kind of event. And the without managing servers part, well, that's the magic. AWS handles all of that infrastructure for you, and you only pay, get this, down to the millisecond for the exact amount of time your code is actually running. No more paying for servers just sitting there waiting. The whole lifecycle is just beautifully simple. First, something happens. That's your trigger. This could be anything, really, like a user uploading a photo to a cloud storage folder, what AWS calls an S3 bucket, or maybe a request coming into your app's API. Second, that trigger invokes your specific piece of code, which we call the handler. And finally, AWS just spins up a totally secure, isolated environment and executes your code. And that's it. Trigger, handler, execution. Simple as that. So all that theory is great, but where does the rubber actually meet the road? Let's take a look at how this technology is used to build some seriously powerful real-world applications.
This is where it gets really cool. So picture this. A user uploads a new profile picture. That action itself, the file upload, can be the trigger. It can instantly fire off a Lambda function that creates thumbnails in a bunch of different sizes. Or think about your mobile app's backend. Every single time a user does something, a request can hit what's called an API gateway, triggering a Lambda function to process it. And this lets you scale from just one user to literally millions, all without you having to lift a finger. You can even use it for boring old scheduled tasks, like running a report every single night.
Of course, no technology is a silver bullet. And to use Lambda really effectively, you absolutely have to understand its trade-offs. So let's talk about the so-called sharp edges, the things you've got to be aware of when you're designing your system.
First up, 900 seconds. Yep, that's 15 minutes. This is the absolute, hard and fast maximum amount of time a single Lambda function is allowed to run. So what does that mean? It means Lambda's not the tool for those super long-running jobs, like, say, heavy-duty video encoding or massive data migrations. It's built for short, sharp, event-driven tasks.
Now, you might have heard of the infamous cold start, right? This is that little bit of extra delay, we're talking a few hundred milliseconds, that can happen when your function is called for the first time in a while. But here's the thing. For most critical applications, this is now a largely solved problem. AWS has rolled out some really powerful features like provisioned concurrency and snap start that basically keep your functions warm and ready to go instantly.
Okay, another key number you got to remember is 6 megabytes. This is the max payload size for what's called a synchronous request. Think of one coming through an API gateway. So if your plan is to send or receive big chunks of data directly through an API call, you're going to need to design your system with this constraint in mind.
And just to kind of round out the picture, there are a few other guardrails. Your actual application code has a size limit, and there's an even smaller payload limit for what we call asynchronous or fire and forget triggers. There's also a default safety limit of 1,000 functions running at the exact same time in one region, that you can always ask AWS to raise that. These are the kinds of details that architects really need to know to build solid systems.
Okay, so we've covered the what, the how, and the limitations. Now let's get to the most important part, the why. Why has this serverless model become so incredibly dominant? What's the strategic advantage here? The strategic value, well, it really boils down to three main things. First, cost. You only pay for what you use, period. There's zero waste. Second, operations. Your team is totally freed from patching servers, planning for scale, all that maintenance. And third, security. This part is just brilliantly elegant. Each function runs in its own tiny, isolated micro-virtual machine called Firecracker, which gives you this incredibly strong security boundary right out of the box.
This quote right here, it just sums it all up perfectly. By taking the servers out of the equation, the operational burden just shrinks dramatically.
Your team can stop worrying about managing infrastructure and instead focus almost all of their energy on writing code that actually delivers value to the business. It's a fundamental shift in how we think about building things.
All right, now for a pro tip that every single Lambda developer needs to know. It's a little bit counterintuitive, but it is absolutely critical for optimizing your functions. When you configure a Lambda, you only set its memory. But what you're also doing behind the scenes is allocating CPU power. Take a look at this. When you increase a function's memory, you also give it a proportionally faster CPU. What that means is your code can finish its job much, much quicker. So, in a lot of cases, doubling the memory can cut the execution time by more than half, which, crazily enough, can actually result in a lower overall bill. That's the key takeaway here. More power can actually be cheaper. It's all about finding that perfect cost-performance sweet spot.
So, we'll just end with this thought. By removing all that friction of server management, AWS Lambda really just opens up a whole world of possibilities. It lets developers innovate faster and build more resilient, more scalable applications than ever before. And it leaves us with one final, and I think pretty exciting question to think about. What could you build?